In this video, we will discuss about operators. An operator is a symbol that tells the compiler to perform certain operation. Operations like arithmetic, logical, relational, etc. C language is rich in built-in operators. First one is arithmetic operators. C language has 5 arithmetic operators. Those are addition, subtraction, multiplication, division, and modulus. So observe this addition operation, subtraction, and multiplication operation. They perform similar to our mathematical operations. Now come to remaining 2 operators. Those are division and modulus. So you observe the difference between division operator in C language and division operator in mathematics. In the case of C language or any programming language, division operator gives quotient as the result. So here in this example, you observe A value is 15, okay, B is 2. By applying division operation, what is the result you are getting? That is 7, which is quotient value. Now observe this modulus operator. Modulus operator gives remainder as the result. Okay, so here you take another example. 4 divided by 3. 4 divided by 3. So here, what is the value here in case of division? Quotient value is 1. Next one is 4 modulus 3. 4 modulus 3. So modulus operator gives remainder as a result. So here remainder is 1. Next, these arithmetic operators case. In the case of modulus operator, you can apply on integers and characters only. It is not possible to apply on floating point numbers. Next set of operators are relational operators. Here we have 6 relational operators. One is uh, less than, equal to, greater than, equal to, is equal to, and not equal to. These relational operators are used to compare different values. And these relational operators gives their result as either 0 or 1. If the comparison is correct, then result is 1. If the comparison is false, then the result is 0. So we observe in this example, we have taken A is 16, B value is 10. A is less than B. So here what is the A value? 16. 16, what is the B value? 10. 16 less than 10, which is false. So what is the result it is giving? 0. So we observe all the cases here. So same values. A is 16, B is 10. In the case of greater than operator, 16 greater than 10, which is true. So result is 1. Now you take this is equal to operator. So you observe here is equal to operator. 16 is equal to 10, which is false. So result value is 0. And 16 is not equal to 10, which is true. So result value is 1. So these are the 6 relational operators which are present in C language. Next operators are logical operators. In C language, we have 3 logical operators. Those are logical AND, logical OR, and logical NOT operator. So first one is see this logical NOT operator. If your input value is false, then result is true. If the input is true, then result is false. That is the operation of logical NOT. Next, you observe this truth table, which gives the how this logical AND operator and logical OR operator performs. So here, if both the inputs are true, both the inputs are true, then only logical AND operator gives result as true. Otherwise, result is false in the case of logical AND operator. Now, you observe this logical OR operator. Whenever any one input is true, then result is true in the case of logical OR operator. Otherwise, result is false in the case of logical OR operator. Now see the example for logical AND operator and logical OR operator. So here you observe three values taken. A is 14, B is 15, C value is 13. So we are using this logical AND operator between two expressions. First expression is A is greater than B. Second expression is A is greater than C. In between those two, we are applying logical AND operator. Now observe what is the value of A? 14. Value of B is 15. 14 is greater than 15, which is false. So its value is 0. Now come to A is greater than C. What is A value? 14. C value 13. 14 is greater than 13 is true. Value is 1. So now on these two we are applying logical AND operator. So here what is one input? 0. What is the other value? That is 1. On 0 and 1 we are applying logical operator. Okay. So then result is 0. Now observe logical OR operator. Same things we are taking. So here value is 0. Here value is 1. On 0 and 1 you are applying logical OR operator. Then in the case of logical OR operator truth table we have seen if any one input is true, result is true. So same you can observe here that result is true. So this is the example for logical AND and logical OR. Next operator is Sizeof Operator. Now what is the purpose of Sizeof Operator? This operator gives how much memory required for the given data type or for the given variable. Here, while writing Sizeof, you have to write as a single word. Okay. Now see the two examples here. First one is int a. You are declaring a as an integer variable. Now you are applying this Sizeof on a. So what is the result you will get? In the case of Windows system or Turbo C, you will get result as 2. Next, in the case of if you are using Linux system or Unix system, you will get result as 4. Next example is float D. So now what is this one? D is a variable. You are declared as a float. So here size of float. What is the result you will get? 4 bytes. That is memory required for the floating point type. Next operator is conditional or ternary operator. So that one is represented by using question mark and colon. So how to write this one? How to use this one? So to write this one, mainly we have to take three expressions. So before question mark, expression 1, between question mark and colon, expression 2, after colon, expression 3. Now here what is the working procedure of this ternary operator? Okay, here observe if expression 1 is true, then the expression which is present in between question mark and colon, that is expression 2 is evaluated. If expression 1 is false, okay, if expression 1 is false, that is no. Okay, in that case, if it is false, okay, if it is false, then expression 3 is evaluated. Okay, that is which is present after colon. Now see this example. We are finding which number is greater number. So a value 10 we have taken, b is 5. Okay, so A is greater than B. So what is the meaning? What is that one? A is greater than B. What is A value? 10. B value is 5. 10 is greater than 5. So which is true? Then automatically the expression which is present, question mark and colon executed. That is A is greater is printed. Okay. If expression 1 is true, observe this one, expression 1 is true, only expression 2 is executed. If expression 1 is false, only expression 3 is executed. Next operator is increment and decrement operator. So here, what is the job of this increment or decrement operator is increment operator increases value by 1, decrement operator decreases value of variable by 1. Okay, now we observe here a is 5 we have taken, a plus plus, which is operator present after variable, after operand, that is post increment. Plus plus a, here what you observe, operator is present before variable, before operand, that is pre-increment. In both the cases value of a becomes 6. Then what is the difference between post increment and pre-increment? Now see the difference between pre-increment and post-increment. Okay, observe in this example, a value 5 we have taken. So b is equal to a plus plus, which is post-increment. In this case, in the case of post-increment, first a value is assigned to b. First, a value is assigned to b. Later, a value is incremented. Now, what is the result you will get? First, you are assigning a value to b. B value becomes 5. After assignment, you are increasing a value. Now, a value becomes 6. Now, see in the case of pre-increment. Okay, increment, okay, before a. In this case, first increment is executed, a value incremented, a value becomes 6. After incrementing, a value is assigned to b, then b value also becomes 6. So now here you observe the b value. In the case of post increment, b value is 5 only. Here b value is 6. That is the difference between pre-increment and post-increment. Okay. Now this example 3 and 4. Okay, these are for decrement operator. So now here you observe minus minus a, which is pre-decrement. So first decrement is executed, later assignment is happened. So first a value 5 we have taken, decrement is executed. Now a value becomes 4, a value becomes 4. After that we are assigning a value to b. So that is the b value also becomes 4. So you observe this post decrement b is equal to a minus minus. In this case, first a value assigned to b. What is a value? 5. B value becomes 5. After that, a value is decremented. That is, a value becomes 4. So you observe the difference between pre-decrement and post-decrement. Next operator is bitwise operators. Okay, so here mainly we have 6 bitwise operators. First one is left shift, right shift, bitwise end, Bitwise R, Bitwise XR, Bitwise Not. Okay. Now see the first one is left shift operator. So main thing we have to observe in the bitwise operators case is these operators works only on binary data. Now see the first one, left shift operator. So we are shifting n number of bits to the left side. That is the main job in the case of left shift operator. Now see the procedure to perform this one. So a value is 25 we have taken. Okay, so a value is 25. First, 25 we have to convert into binary form. You all know how to convert into binary form. Divide 25 with 2 until you will get quotient value as 0. All the reminders we have to take from bottom to top. So by taking that one, you will get this one 11001. So here, assume you are using Windows system. So Windows case integer requires 2 bytes memory. 2 bytes means how many bits? 16 bits. So here we are representing A in the form of 16-bit form. Already 5 bits are filled. That is 25 you converted into the binary form. Remaining 11 bits you fill with 0. That is the first step. Convert A value to binary form. So next we have to shift bits n positions to the left side. N positions to the left side. Assume if your n value is 2, that means 2 positions you are shifting left side. If you shift 2 positions left side, leftmost 2 bits you are going to lose. Okay, then this one becomes to this position, that is 2 positions left side. Every bit we are shifting, so like that. So this one comes to this position. Okay, so this one comes to this position. So every bit shifted to 2 positions left side. After shifting, this last rightmost one comes to this position. So what you observe here, rightmost 2 positions becomes empty. Those two you have to fill with the zeros. Okay. So that is the second step in the case of left shift operation. After shifting n number of positions left side, now the resultant one we have to convert to the decimal form. So like this you will get b value as the 100. That is the procedure to perform left shift operator. Next operator is right shift operator. So now see the example. Here also a value is 25. In the case of right shift operator, first step is convert a to the binary form, which is similar to first step in left shift operator. Next, in the case of second point, you have to shift bits n positions to the right side and fill the empty locations with 0. Now see this one, 25 converted it to the binary form 11001. Remaining 11 bits you have to fill with 0. Okay, so after that, assume your n value is 2. 2 positions you are shifting right side. So that is this one you are going to lose, and this one also you are going to lose. That means 2 bits you lost, which are present on the rightmost side. This one comes to this rightmost position. So that is 0 comes to this position. 1, 1. These are shifted to this one. These 3 are filled here. Okay. And like that, every bit is shifted to 2 positions right side because our n value is 2. So in that case, leftmost 2 positions becomes empty. Those locations you have to fill with 0. So after performing this one, we have what is the resultant one you got, which you got, that one you have to convert to the decimal form, that is b equal to 6. So that is about right shift operator. In bitwise operators, we are left out with bitwise and bitwise R and bitwise XR. Okay, so now see bitwise AND is represented only single ampersand, bitwise R and bitwise XR. Now see the operation of these three operators. Bitwise AND value is 1 only when both the inputs are true. Both the inputs are 1. Okay, next one. Bitwise R operator. Bitwise R operators are true, that is value of bitwise operator is 1 whenever any input value is 1. In these three cases, bitwise R operator value is 1. Okay. Next one is what is bitwise exclusive R? So that is uh, if values are differ, that is input values are differ. Okay, then only bitwise uh, XR operator result is 1. Okay, here you observe 0, 1, result is 1. If input is 1, 0, then result is 1. Otherwise, result XR operator result is 0. Observe if both the input values are same, then XR value is 0. If both the inputs value are differ, then XR result is true, that is 1. Now see the operation of bitwise AND. So here example, A value is 25, B is 64. Okay. So first step is we have to convert A and B into binary form, represent in 16-bit form because we are discussing this one in Windows system. Okay, A value 25, we are converting this one to the binary form. Okay, remaining 11 bits we are filling with 0, and B value 64 we are converted into binary form. Remaining 9 bits we are filling with zeros. Now AND operator we are applying on A and B. When AND operator 1 value is 1 whenever if both the inputs are 1. Okay, here you observe in all these cases both the inputs are 0, so automatically result value also 0. Here 0 1, so result value is 0. Here 1 0, result value is 0. Here 1 0, result value is 0. So total you got all the bit positions are is zeros. So final result we have to convert to the decimal form, which whose value becomes 0. Next one is bitwise R operator. Here also we have to convert given inputs into binary form. After that we have to apply bitwise R operator. So when the result is 1 in the case of bitwise R operator, if any one input is true, then result is 1. Okay, here you observe 0, 1. So result is 1. Here you observe 1, 0. So result is 1. Here you observe 1 0, result is 1. Here you observe 1 0, result is 1. In remaining cases, both the values are 0. That's why result is 0. So this is the result you got in a binary form. That one you have to convert into the decimal form. So total result becomes 89. Next one is bitwise exclusive OR. Bitwise exclusive OR. Given two inputs, we converted into the binary form. Okay. Then how to take the result? If both the input values are differ, then result is 1. So you observe here 0, 1. Both are differ. So 1 the thing. Here 1, 0. Both the input values are differ. So result is 1. Here 1, 0. Both the inputs are differ. Result is 1. Here 1 0, both the inputs are differ, result is 1. In remaining all the cases, both the inputs, A value is 0, B value is 0, that is both are same, so result is 0. So this is the binary form, we have to convert into the decimal form. This is the resultant decimal value for C. Next one is bitwise not. Okay, so in this case, given input, we have to convert into the binary form and represent in 16-bit representation in Windows system. So we have to replace 0 with 1 and 1 with 0. That is the result you will get in the case of bitwise not. So observe the main thing, bitwise operators perform their operation only on bitwise data, only on binary data. Next operator is assignment operator. So here, what is the job of assignment operator? For the operator, the expression value which is present right side, that one is assigned to left side variable. Okay, now you observe here, x is equal to a plus b. A plus b value is calculated. After that, its value is assigned to x. So here observe, arithmetic operator evaluates an expression on the right side and substitute its value to the left side variable. Okay, so here you can represent this assignment operator in the shorthand form also. When, okay, for example, you see this one on left side and right side of assignment operator, if same variable is present, and that one you can rewrite like this. So here you observe x is equal to x plus 1. So x is present on both sides. That one you can rewrite x plus equal to 1. So for example, a equal to okay, so here, for example, if you take some y is equal to y minus 1, y minus 1. Okay, so on both the sides of assignment operator, we have same variable y. So that one we can rewrite as y minus is equal to 1. Now, these are the some of the special operators. First one is address operator, okay, and next one is dereference operator or pointer operator, dot operator, and this is arrow operator. First two you can come across in pointers topic. Remaining two you can come across in structures topic. Now, what do you meant by unary operator and binary operator? So here you observe minus 2 is present. Here 3 minus 2 is present. In both the places we have the minus. Okay, subtraction. In both the cases we have the minus. In one case that is called as unary operator. In other case that is called as binary operator. If operator works on only one operand, then that is called as unary operator. Okay, here you observe here minus 2. Only 2 is only one operand is present. So now what is the purpose of this one? To represent this is a negative number. We are using this minus 2 like that. Okay, in that case, that is unary operator. It is performing its operation on only one operand. Okay. Then that is called as unary operator. Now see the second one. 3 minus 2. This operator is performing its operation on two operands. So that's why it is called as binary operator. Okay. So in the first case, it is used to represent either negative or not. In the second case, you are calculating the difference between two values. Next is expression. What do you meant by an expression? An expression is a sequence of operands and operators that reduce to a single value. So here expressions may be simple expressions, expressions may be complex expression. In simple expression, you will have only one operator like that. In complex expression, we have multiple operators. Now, what is an operator? An operator is a syntactical token that requires an action to be taken. So this informs to the compiler what action to be performed, what operation to be performed. Next one is operand. Operand is an object on which an operation is performed. Okay, so here you observe, for example, A plus B. So this is one simple expression. In this case, this plus is the operator and A and B are the operands. So on A and B, you are performing addition operation. So plus is the operator, A, B are the operands. Now come to expression evaluation. So how to evaluate one expression? So here you observe some examples. A is equal to 2 plus 3. Here no problem. 2 plus 3, addition is performed, value is 5. So A value becomes 5. B is equal to 5 divided by 4. So division is performed on 5 and 4. You will get result as 1. So B value becomes as 1. Now see this third example. 2 plus 3 multiplied by 6. Okay, here which operation to be performed first? For example, if addition is performed first, that C value becomes 30. If multiplication is performed first, C value becomes 20. How to avoid this ambiguity? How to determine which operation to be performed? To get that one, we have to use associativity and precedence. Now we will discuss precedence and associativity. First, precedence. So what is the use of precedence? In an expression, if more than one operator is present, then which operation is to be performed first? That is determined by the precedence. The operator whose precedence value is greater, that is to be evaluated first. So here see the definition. Precedence is used to determine the order in which different operators in complex expression are evaluated. Next one. What is the use of associativity? So here in an expression, if two operators are present, both have same precedence. In that case, which is to be evaluated first? Which is to be performed first? That decision is taken by using associativity rules. So the associativity can be left to right associativity or right to left associativity. Now we will take the precedence table and associativity table. Here is the table for precedence table. Okay, so here the operator which has precedence value 1 is the highest priority. So that is a highest priority. That is the operator which has precedence as 1 is highest priority. So now observe here, first operator is parenthesis or function call. Next one is bracket or array subscript. So member selection or dot operator, member selection via pointer. So these operators has the highest priority. Okay, and whose associativity is the left to right. So next, second highest priority, increment or decrement, unary plus minus, logical negation and bitwise complement, typecasting operator. Okay, so dereference operator, address operator, Sizeof operator. So these operators has the second priority. Next one is multiplication, division, modulus operator has the third priority. Okay, so addition, subtraction has the fourth priority. Bitwise left shift and right shift has the uh, fifth priority. Okay, so and second last one, last column we observe, that is associativity. For example, in one expression, if both multiplication and division is present, which is to be evaluated first? Okay, so for example, we observe this is the expression 2 multiplied by 3 divided by 2. Okay, so now which is to be evaluated first, either multiplication or division? Here in the table you observe both multiplication and division has the same precedence. Okay, so if same precedence you observe in an expression, then we have to go for the associativity. So what is the associativity? Left to right associativity. So we have to evaluate operators in the expression from the left to right. So what is the first left one which is present? Multiplication is present. So 2 multiplied by 3 is 6 divided by 2. Okay, so then whose value becomes 3, whose value becomes 3. So like that we can use precedence and associativity. So this table is continues in the next slide. Now see the next operator, less than equal to, greater than equal to. So they have precedence sixth level and their associativity is left to right. Next one is equal to, not equal to, left to right associativity precedence is 7. So bitwise and eighth precedence left to right associativity, bitwise exclusive or ninth precedence left to right associativity, bitwise inclusive R. Okay, simply you can take as bitwise R operator, 10th precedence and left to right. Next, logical and 11th precedence, logical R, that is 12th precedence, ternary operator, okay, that is 13th precedence, right to left associativity. And all these are, one is assignment operator. These are all shorthand assignment operators. The 14th precedence and right to left associativity. Last one is a separator, that is a comma operator, whose associativity is the 15, which is the least uh, precedence. Okay, whose precedence is 15, which is the least value we have to take, and associativity is the left to right associativity in this case. Okay, so the operator which has precedence value 1, that is that has the highest precedence. So the operator which has precedence value as 15, that has the least precedence. So from 1 to 15 precedence level decreases. Okay, so in the case of associativity, some are left to right associativity, some are right to left associativity. So to evaluate complex expressions, mainly we have to follow this precedence table. Thank you.